Welcome back, my shining stars. This is Hershey, your science mentor. Today I am taking up the chapter number 10, Fun with Magnets, of your course book Science Horizon, Class 6, Acknowledged series by Amit Publishing House. So let's see what we are learning today. We learn about the discovery of magnets, types of magnets, magnetic and non-magnetic materials, two poles of a magnet. Let us make our own magnet. Yes, temporary and permanent magnets. We'll also learn about pursuing magnets, serving uses of magnets. This all we are going to cover about magnets in this chapter. So let's start with the chapter. Have you seen a magnetic door? Magnetic door, what is it? Magnetic door is a door in which magnets are fixed and it closes automatically, and this door you'll find in refrigerators. So one of the common example of the door is refrigerator. When you leave the door open, so slightly open, so what happens? It shuts automatically. Yes, it is a magic. No, it happens because the door of refrigerator is having magnet inside it. There are some more examples like the pencil box lid. When you leave it open, and the magnet will attract, and the lid is closes automatically. Your mother's wallet, yes, it also has magnet, so which close automatically. The word magnet has been derived from the word magnetite. This is the word magnetite from which we got the word magnet, which is in Latin and which means magnesia or manganese. Yes, manganese, magnesia, and it is the meaning of the Latin word. What is the Latin word? It is magnetite, and from which we derive, what is derived, what is driven from this? The magnet, this, the word magnet, right? So, discovery of magnets, how it got discovered, we will see today. This is a story, it is very interesting story. Magnets were probably discovered by Greeks about 2500 years ago. And how it got discovered? The story about the discovery of magnets is very interesting. You can see a boy, he is a shepherd, and he has a stick which has iron plate at the bottom side, right? Let's see the story. Shepherd named Magnets. The name of the shepherd was Magnet. So because of his name, it got this substance got name, which is magnet. So lived in ancient Greece. What happened after that? He used to take his sheep to the nearby mountain for grazing. So it is a work of shepherd, right? So he took his sheep to the nearby mountain. The stick he carried with him to control his sheep had an iron tip on one side. So one day what happened, he noticed that suddenly it got stuck with a rock. So one day he noticed that iron tip, it got stuck on a large black colored rock. So after investigation, the Greeks found what? The rock had the property of magnet. It attracts the iron. Yes, magnet attracts the iron pieces. The black rock was named magnetite, perhaps after the name of that shepherd. So this is how it got its name, because of the that shepherd, because that person, it was the name of his, and it got its name magnet. And it is also said that magnets was first discovered in Magnesia. This shepherd used to live in Magnesia, right? So the pieces of magnetite were called magnet. So that was the natural form of magnet which was found in Greece. So this is called, that rock is called magnetite, and the pieces of that rock, means the pieces of magnetite, is known as magnet. It has how now been established that magnetite is a natural occurring magnet made of iron, right? Magnets are substances that have the property of attracting materials. It attracts some materials only. This magnet doesn't attract everything towards it. Some materials it attracts, and these are iron, cobalt and nickel, right? Three materials it attracts: iron, cobalt and nickel. So types of magnets. Magnets can be grouped into two. One is natural magnet and another is artificial magnet. So natural magnet is simple as name refers. It is the magnet that we found in nature. We get in nature and mostly found in rocks. So magnetite is an example of natural rocks. So these are some different shapes of magnet and its sizes, right? Magnets can be uh, crafted in different shapes. This is called the bar magnet. It is in bar shape. And this is horseshoe magnet. Because of the size, it got the name. It looks like the shoes of horse, so that is why this is known as horseshoe magnet. This is U-shaped magnet. There is slightly difference between these two, right? So it is in U shape, that is why it is known as U-shaped magnet. And this is horseshoe magnet. Now next is cylindrical magnet. Button magnet, it is small and the shape of buttons, and the ring magnet, right? So these are some different shapes of magnet, right? And the artificial magnet that we know, it is grouped into two: natural magnet and artificial magnet. So artificial magnets are those magnets that are made by men using iron, cobalt and nickel. I told you it attracts three materials man-made by using iron, cobalt and nickel. So according to the requirements, artificial magnets are made in different shapes and sizes. The shapes and sizes that we have seen in the last picture, so these are made by man, right? So that is why these are called artificial magnets, and the natural magnet is in the form of rock. So artificial magnets are in different sizes and shape, like disc shaped magnets, horseshoe magnets, cylindrical, bar, ball ended magnets, etc. So now we know that how it got discovered, and what is the artificial magnet, what is the natural magnet, and the shapes and sizes of the magnet. Now magnetic and non-magnetic material, right? So a magnet does not attract all kind of objects. As I told you, it is not attracting everything, otherwise सब कुछ चिपक जाता. So it attracts only a few and leaves the rest materials. So on the basis of attraction, it can be again the materials which are attracted by this magnet. It is known as magnetic material, and the materials which are repelled by the magnet or it is not attracted by the magnet, it is known as non-magnetic materials, right? So first we will see the magnetic materials. The materials which get attracted to magnets are called magnetic materials, and these are iron, cobalt and nickel are some magnetic materials, right? And again, non-magnetic materials are those materials which are not attracted by magnet, means except nickel, iron and cobalt, everything is non-magnetic. So the materials which are not attracted to the magnets are called non-magnetic materials. For example, paper, wood, plastic, stone, clay, cotton, etc. are the non-magnetic materials. Are we clear about this? Magnetic and non-magnetic materials. Magnetic materials are iron, nickel and cobalt, and rest the materials are non-magnetic materials. So let's move ahead. These are example: paper, wood, these are logs of wood, rocks, flowers. So all these are non-magnetic materials, right? Now another thing, now we got to know, we have idea that the what is like the magnet attracts what, right? It is not attracting what, and how it got discovered. And now we will learn about the two different poles of magnet. So what is this? Poles means side. So two poles, a magnet has two poles, right? Earth has two poles, now North Pole and South Pole. Yes, but Earth has two poles. One is the North Pole, another is the South Pole. And magnet spreads some iron filings on a paper sheet. So now what is filing, kids? It's a scratch, or when we scratch the iron, so it's a powdery form of iron. So iron filings on a paper sheet. Take a paper sheet and spread some iron filings on it. Roll the bar magnet or bring it close to the iron filing. So let's say this is the paper and this has a lot of iron filings on it. So when we have a bar magnet in our hand, when we move onto it, so what will happen, right? It attracts it, right? Everything or most of the iron filing will be attracted and will stick with the poles, right? You'll see the both ends. These are the ends of the magnet. Let's say it is a magnet which has North Pole and South Pole. This is the bar magnet, North Pole and South Pole, and we are moving it on the paper on which the iron filings are spread, right? So it attracts on the both of the ends. The iron filings will be stuck, right? So these are the North Pole and South Pole, and we denoted with the N and S. So the magnet has two ends and they are called the poles. Iron filings get attached to these poles, and one is North Pole and another is the South Pole, right? So the poles of a magnet are represented by N and S. You can see in this picture also, like this is the magnet which has the North Pole and South Pole. For your observation, it is again colored picture, so you can identify this easily. The red portion is there, it is North Pole. In actual, magnet is not having any color, but for the beautification and just to understand the poles, just to identify it, it is colored. Like, so the blue one is the south pole. This is the bar magnet, and you can see the iron filings here, right? It got stuck. So it attracts the iron, nickel and cobalt. These are known as magnetic materials. Now study about a magnet shows NS direction, not south direction. A freely suspended. Now what is freely suspended? When you suppose you have a, this is the bar magnet, and you tie a thread here and hold a side of a thread in your hand and let it just give a shake to it, and it will move, and it will always rest in north and south direction. Yes, you can do this at your home. Take a bar magnet, tie a thread on it, and hold the end of a thread in your hand and just give a shake like this. It will always rest, it will always stop in north and south direction. So always comes in rest in the north and south direction. But let me give you some extra information which is not included in this book. So what is it? As we all know, the earth also has north pole, which is upper side, and the south pole here. How these poles have defined? So it is defined with the equator. Again, this is the imaginary line which divides earth into two equal halves, and with the upper side is called the northern hemisphere, and that is why this pole is known as northern pole or north pole, and this is from the equator. This is going towards the distance between from equator to this pole, it is known as southern hemisphere or south pole we call it. You know, one interesting thing is that earth is also having magnetic properties. It is also a magnet. It acts like a giant magnet. It is a giant magnet, but it is not as active as other. You can say it is a weak magnet. It is not strong, right? But earth acts like a magnet. It is having magnetic properties. So why I am telling this to you? So we have come to know that magnet also has two poles, north pole and south pole. Earth also has north pole and south pole. So is there any link between these, the earth and the magnet? Why I am telling you this? I am telling you that the earth has north pole and south pole. So let's see, kids, we have this bar magnet with us. This having north pole and the south pole. The earth is also having north pole and south pole, yes, but actually these poles are different from these poles. Like, if it is the north in this magnet, this is the north, so the earth south pole is actually the north pole of a magnet. It is reverse in case, right? Don't get confused in it. Give a little time to it. You will understand this. अगर मैग्नेट का नॉर्थ पोल ये है और अर्थ का नॉर्थ पोल ये है, तो these are not same. If you keep it like this, let's make another magnet. This is the north pole and this is the south pole. As it is an earth, but it is reverse in the case of earth. The north pole is actually the south pole of Earth, and the north pole is actually the south pole of magnet. Yes, it is different. Although Earth is a weak magnet, but the north pole and south pole of Earth is reversed as compared to the magnet that we have. The magnet has not one, this pole is actually the south pole of the Earth, right? So when we are tying a bar magnet, give a thought to it, give little bit time to it, pause the video and understand it again one more time. You will come to know and give a thought, and just close your eyes and understand this. You will get it. Now you are getting confused, but if you repeat it more and more times, you will understand this concept that the poles of a magnet is not similar the poles of the earth. Earth also acts like a magnet. It is a giant magnet, but it is weak magnet. We will also discuss what are the strong and the weak magnets later, right? But here, understand it acts like a magnet. It has two poles, north pole and south pole, right? So north pole is actually the south pole of a magnet, and the south pole is actually the north pole of a magnet. You can understand with this. Let me go one more time. This is a magnet. Now this time I will show the south pole here and the north pole here. So these are same. Magnet south pole is actually the north pole of the earth. So there is a difference between the earth pole, north pole and south pole, and the magnet pole, right? So freely suspended magnet always come to rest in the north-south direction. So when it moves, give a shake, as I told you. Tie this bar-shaped magnet with a thread and hold this thread. Give a shake like pendulum. It moves here and there, and where it will stop, it will always stop in the north and south direction. But if it is the north of a magnet, then you can understand it is the south direction of the earth. Now relate with it. If the north pole and south pole is here, if magnet is stopping, it is showing the north pole here, but actually this is the south pole of the अर्थ. तो ये चीज समझना जरूरी है कि अगर अर्थ का साउथ पोल है तो मैग्नेट का वो नॉर्थ पोल है, राइट? नेक्स्ट इज अट्रैक्शन इज मैक्सिमम एट poles. Now we are discussing about the magnet. We are not discussing about the earth. This is the extra information which I have given to you. Attraction is maximum at poles of a magnet. It is because these points have maximum magnetic strength, means the poles are more stronger as compared to the middle portion, right? In fact, all the power of magnet is concentrated at the poles. ये poles से ज़्यादा strong है, बीच में नहीं. So maximum power is concentrated at the poles. We have seen in that last example, the iron filings got stuck with the poles only. It was not stuck in the middle portion, right? So the magnetic force keep on decreasing and becomes negligible in the center. You can see it is very weak from center, or magnetic force is decreasing, or you can say it is negligible, means it is not having the magnetic property in the middle section, right? So moving to the next property, which is poles have equal capacity to attract. Both the poles of a magnet, it does not make any difference whether the North Pole is attracting more or the South Pole is attracting more. No, it is strong at both the ends, right? So both the poles of magnets have the same capacity to attract what? The magnetic materials. And what all are these? Iron, nickel and cobalt. I am repeating these things again and again so that you will remember this. Now, the fourth one is the poles of a magnet can never be separated. Yes, these are the best friends. It cannot be separated. You cannot separate it. Suppose you have a bar-shaped magnet. Yes, and you break it. Let's understand with this. It is the bar-shaped magnet. It has two poles, North Pole and South Pole. Yes, we have broken down from middle. Now, what will happen? South Pole has gone. No, again South Pole will be formed here. Now we have these two magnets, one magnet and this is the second magnet. This will also have the North Pole here, right? So, the one magnet, bar magnet, is when we break it into two, again two poles will be made, the North Pole and the South Pole, right? Let's see one more time. If it is again broken into two, so this is the North Pole and this is the South Pole of the magnet, and this is the South one and this is the North Pole of this magnet. So you can break it as many times you want, right? And it will form again North Pole and South Pole. You never ever can separate the poles of a magnet. So are we all clear, kids? Very good. So just read it out. The two poles of a magnet can never be separated. This means that poles of a magnet already exist in a pair in piece of magnet. If we break a magnet into two halves, each one will have North Pole and South Pole. Again break it. Again you'll have North Pole and South Pole, right? So moving on to the next property, which is similar poles repels, opposite poles attract. Yes, this is another feature of magnet. Similar poles of magnets repel. Repel means dur hatana, bhago bhai. I am not, you are not, bhago bhai. I don't want you. But if it is a North Pole and South Pole, they are friends. They attract each other. So while the opposite poles attract each other. So opposite poles means the unlike poles, and the similar poles means like poles. Like poles, what? They repel each other. दूर हट जाएंगे एक दूसरे से. And the similar poles or like the unlike poles get attracted to each other. You can understand with this. We have two magnets, North Pole and South Pole. Again, another one. This is having the South Pole and North Pole. What will happen? Just tell me quickly. South Pole, South Pole. What happens? What will happen? It will repel. Will not come close to each other. It will not attract each other, right? But we have two magnets, North Pole, South Pole, and if the South and North Pole is here, this is the South Pole, they will be attracted to each other, right? One South Pole and North Pole will be attracting to each other, while the similar poles like north or south will repel each other. This is the property of magnet. So have you understood this property? Now let's move on to the repulsion property. We have already discussed in this. Repulsion is the surest test of magnetism. This means that repulsion property is used to test whether the given object is a permanent magnet or not. You can see that We will see what is a permanent magnet and the temporary magnet, right? We'll discuss it later on. Just have patience. But here, repulsion is being used to test whether the magnet is temporary or it is permanent magnet. So we can test if the poles are not shown on the magnet, that how we will identify which pole is what, and how we will see this magnet is temporary or permanent. We will see, we'll discuss what is this, what all the permanent and the temporary magnets are. But to check, this is the check, the repulsion property means the unlike poles, north and south pole will attract each other. Rather, north and north will repel, south and south will repel each other, right? So this is the repulsion property. Now, what is temporary and permanent magnets? We have just discussed to test the temporary magnet or permanent magnet. The repulsion test is there. Now we will discuss what is it, what is the kind of temporary and permanent magnets are. Some magnets lose their property of magnetism after a short period of time. So these are called temporary magnets. These magnets will lose their property of magnet, means magnetism will be lost after some time. So the magnet that do not lose their property of magnetism even after a long period of time, so these are called permanent magnets. So you will see the repulsion only in the permanent magnets, or with the help of repulsion test you can identify that this magnet is permanent magnet and this is the temporary magnet. So how you will do is, you have a permanent magnet in your hand, two pieces of permanent magnet. When you attract each other, like the north pole and the south pole, this will be attracted because these are unlike poles, and the like poles will be repelled. So repulsion test through which you can identify the permanent magnets, and the permanent magnets are those magnets that do not lose its magnetism property for a long period of time, right? So now next is preserving magnets. How we can preserve the magnets so that the magnetism property will be stays in the magnet. So permanent magnets can lose their magnetism and get demagnetized if they are no thrown or dropped from a height. Like if you have a if you have a magnet in your hand, you throw it from the height. It does not mean that it is you are throwing it for breaking it. It is not there. But you throw it from a height, many times it will lose its magnetism and hammered or heated. When you heat a magnet, again this will lose its magnetism, and when it is hammered, right? When you hammer it, and again the magnets will lose its magnetism. So we need to prevent the magnets from getting the magnetism lost from these. So a magnet can also lose its magnetism if it is not stored properly. So we needed to be very careful while handling and storing magnets. How we can store it? Bar magnets are the most commonly used magnets. So we must know the right method how to store it. You can see in this picture, these are two. This is the first bar magnet and this is the second one bar magnet. So bar magnets are most commonly used magnets. So we should store them properly so that magnetism can be stayed in it. So this is, you can see in this picture, this is the north pole and this one is the south pole. So keep it in this way that the unlike poles are there. So this is the north one, and then you keep it the south pole, right? So unlike poles are kept, and between these two bar magnets there is a wooden piece. Keep always a wooden piece. Wooden is a material that does not attracted by the magnet. So we keep like this. This is the wooden piece, right? We will keep wooden piece between the two magnet bars, and these magnets are kept according to the unlike poles. And here is a soft iron strip which is kept on the upper side as well as on the bottom side, and this will keep your magnet safe, right? It will not lose its magnetism property. So the bar magnet must always be kept in the pair with the opposite poles on the same side. A piece of wood should be kept in between to separate them because this is the non-magnetic material. Two bars of soft iron should be kept across these ends, and these soft iron bars are called magnetic keepers. We call them magnetic keepers. So bar magnet with the bar keepers. So this is how we can protect the magnetism of the bar magnet. Now let's see in case of horseshoe magnet, a single magnetic keeper should be. Now what is magnetic keeper? We have just discussed. It is the iron bar. So we can keep like this. This is again magnetic keeper, and we can keeper. It is made with the iron. So this is the iron bar. We can keep in this position, North Pole and South Pole. It is the two different poles, and in this way we can protect the horseshoe magnet, right? It will be long lasting. The magnetism of these magnets will be long lasting. So it is also important to take certain precaution while working with magnets. Now what all are these? Magnets must be kept away from what? From the tape recorders, computers, CDs, televisions, radios, transistors, remote control devices, credit card, as well as the audio and video cassettes. We should keep them away. We should keep the magnets away from these electronic appliances because these appliances also have magnets in it. So the working of these things get affected by the presence of the magnets. These objects may get demagnetized. Now what is demagnetized? Demagnetized means it is not having any magnetic property now, but earlier it was having like a magnet. Earlier it was a magnet, it is a temporary magnet, but now it is not having the magnetic property, so we call it demagnetized magnet. So demagnetized means it has lost the magnetism. So we should keep the magnets away from the remote controls, from the radios, from the tape recorder, television, CDs, even our debit and credit cards also, because it has electronic strip on it, and this strip is also having some portion of magnet. So we should keep the magnet away because these things will what? Demagnetize. Now uses of magnets. Here is a picture of ATM card. ATM cards means the credit and the debit cards, etc. Your parents must be having these credit cards and debit cards. So we have a magnetic strip. This black strip, the black color strip, this one. This is the magnetic strip that stores information and enables transaction of money. When we go to the ATM machine and we insert our debit card, so our data or the information that bank has stored in this magnetic strip. Lot of information, account number, amount, everything is like it is linked with this magnetic strip when you insert it. So you'll find that your account is there and you can do the transaction. So if the magnet is kept nearby this a debit card or credit card, so this card can lose its magnetism or can get demagnetized. So have you understood, kids, what is demagnetism? Right? So we should keep it away. Magnetic recording devices such as VHS, audio cassettes, floppy disks, hard disks have magnetic material coating for what? For recording data. So that is why we should keep the magnet away from them. Powerful magnets are fitted in motors, generators and loudspeakers. So these are also fitted in fridge doors, almirahs, etc. At home. Refrigerator, the example that I have given you in the beginning of the chapter, refrigerator also have magnet fixed into it, and because of this the magnets attracts each other and door shuts, right? Unlike poles, and it got shut. Similarly, the wallets also has magnets in it. It attracts and wallets gets shut with this. So loudspeakers, generators and motors, almiras also. Nowadays the almiras, the wooden almiras also are like equipped with the magnet, and because of this the door gets shut automatically, right? Now the magnets are used in scrap yards, the dumping ground, scrap yards, to separate iron from the scrap to of different materials. Here you can see this is the magnet. This is the magnet. This is the giant magnet, and it is attracting the iron, nickel, and cobalt towards it. You can see it is getting attracted by this, and what will happen? It will go and stick with the magnet. So they are the scrappers are using it for scrapping the iron, nickel, and cobalt, extracting it from the scrap, right? So a magnetic compass. Now compass, you can see, you must be using at your homes also. You must have seen it. This is a magnetic compass instrument that uses a magnet to find direction. How we find the direction if we are moving somewhere, we don't know there is north, west, south, east and west, like so we can use this magnetic compass. It is actually having magnet inside it, right? It is used by mariners to find direction under water. Underwater also we can find the direction because of this magnet compass. So it is also called mariner's compass, right? We find the direction with the help of this compass, and it is marked, it is always dressed in north and south direction. It has a small magnetic needle at the center. It rotates freely and always point to the north and south direction, right? Now, next is maglev or magnetic levitation is a method by which an object is suspended with no support other than magnetic fields. This is the example. You can understand the statement with this example. This is a train which is not having any wheel onto it. How it is connected with the magnets only. You can see here there is no wheel. You see this in your books clearly. It is developed in Japan and China. These trains are without wheels and move a little above the rails, right? Above the rails it is moving. You see here, right? This is. The trains are pulled by the magnetic force that acts on will. So it is moving because of the magnets only. And this type of trains have developed in Japan and China. So this is all about the magnets. So let's recall what we have done till now. Magnets was first discovered as a large black rock in ancient Greece. The Greeks called this rock magnetite. It got name magnetite. Magnet is a substance that has the property of attracting metals like iron, cobalt and nickel. Right? So these are being attracted by magnets and that is why they are called the magnetic material. On the basis of their occurrence, magnet can be classified as natural and artificial. You will find the magnet in nature and you can make it, right? So we will get this artificial and we can classify them into natural and artificial methods, artificial magnets. A magnet attracts some object and leaves the rest. These will be attracted by the magnet only. A magnet has two poles, north pole and the south pole, right? A freely suspended magnet comes to rest always in the north-south direction. Attraction is maximum at the poles and it is very low or negligible from the center, right? Have the same capacity to attract. Both the poles attract and having the same capacity for attraction. Two poles of magnet can never be separated. Our earth behaves as a giant magnet, right? So these are some points that we have learned. Now it's time for the question answers. Name the magnetic rock found in Greece with the magnetic property. It was magnetite. Name any two magnetic materials that you have at home. The wallet, the ATM cards, means debit and credit cards we have at home. We have the almiras. It has the magnets, right? And the remote controls and the tape recorders, the CDs, the hard disk. So many examples of the materials, even motors also. What is attraction and repulsion of magnet when like poles are near? They are showing the property of repulsion. And when the unlike poles, means now north and south poles, they'll get attracted by each other, means like poles shows the repulsion and unlike poles shows the attraction. So give one use of magnet. We have seen so many uses of magnet. You can write down any of your choice. Name the instrument used for finding direction, which is the magnetic compass. How will you identify the poles of a magnet? We have seen it. We'll find it through the repulsion test, right? What do you understood by non-magnetic materials? The materials which is not having magnetism is known as non-magnetic materials. What happens when a bar magnet is freely suspended? It will always rest in north and south direction. But the north pole and south pole are different from the bar magnet. The Earth's north pole and south pole are different from the north pole or south pole of magnet. It is actually reverse. Mention what happens when a bar magnet is cut into two halves. It will again having the north and south poles. North and south pole cannot be separated, right? So this is all about magnets, kids. Hope you have liked the session, right? I will connect you in the next class or the last chapter of your course book, right? Till then, stay excited for clamp of another videos. Bye. Have a nice day.